Yay! Wow, so many people. Very exciting. Thank you all for coming today. Yeah, let's just jump right into it. Thanks, Kani, for the introduction. All right, so before starting to talk about what JavaScript is, I just want to start with myself. Who am I even? Why am I speaking about JavaScript to you? Where do I come from? So my name is Felix. Don't try to pronounce my last name, it's going to fail. I'm from Germany. I've been, well, Kanye likes to say I've been born with a keyboard, basically. Always been interested in software, kind of taught programming on to myself. I've worked with tons of languages and frameworks and tags. Like just professionally, it would be C#, C++, PHP, JavaScript, Python, Ruby, Java, TypeScript, and Haskell. Way too many. And I've experienced writing applications for the web, mobile, embedded, and desktop. So I do like to say that I can provide some kind of insight into the goods and bads of the choices you make when starting a new project. And I myself, so my first professional job was using PHP and JavaScript. And I myself, even at that time, still new, kind of developed a little dislike for the language. And it was actually after a very similar talk to what I'm giving to you guys today, where it kind of clicked, kind of light bulb flashed, and I understood, oh, this is why it's a thing now. This is how it becomes so important. So what I'm trying to achieve with this meetup, with this talk, is to transmit that same feeling to you, to make you understand, okay, why is JavaScript becoming this big thing? But to understand how things got to where they are now, we have to go back to the very roots. So, who knows what this logo stands for? Netscape, yes. It's 1994, I think. I was just 3 years old at that time, so I probably pooped my pants. But yeah, Netscape. Netscape Navigator. It looked kind of like this. This is it running in Windows XP. You guys remember Windows XP? That was horrible times. Didn't want to die, but well. And Netscape Navigator was one of the first browsers. It was before Internet Explorer, before Firefox, before Chrome. And it was actually a browser you had to pay for. Can you imagine that nowadays? Like you just bought your new Mac, you open it up, you want to open up Safari or Chrome or Firefox, and it's like, you got $5? No? Well, too bad. Well, anyways, so this browser was used to display web pages. And that's the thing. People didn't want to just display things. People wanted to interact with their web pages. So what Netscape did is they said, hey, someone please develop a language for this? And they had an employee, his name was Brendan Ike. And he kind of developed what would later be called JavaScript in a day. And we kind of feel those consequences still now. We're going to talk about that too. And then they wanted to launch it together in cooperation with Sun Microsystems, a company called Sun Microsystems. They are mostly known for a programming language called Java. And they decided to call it JavaScript. Now, why do you think they decided on that name, JavaScript? Any ideas?
Because Java is very hot nowadays.
Yes, because Java at that point was just very popular, and they were afraid that when they launched their new fancy language, nobody's going to pick it up. You got to remember, they're still one of the first browsers, right? So they want to have an impact. And we still feel that impact now when people come and say, oh yeah, I know Java, I can code JavaScript. So thanks, Netscape, for that eternal confusion, because these two languages have nothing in common with each other. They just completely different languages. Anyway, so now they had a language to kind of modify little elements on their web page. You would do that usually with Macromedia Flash or Adobe Flash. I'm glad that died out. But it was still little things, like make something pop here, move an element to the side. But at that point, you wouldn't really call it web applications. So, but let's talk about those web applications. Let's talk a bit about Twitter, and especially what I love to call the failware. Well, not just me, it's actually the name of the thing. So, Twitter. How did Twitter come to be? Twitter was just created by 4 friends. They want to make money. And so they decided they want to make a little service where people can write short blips about themselves, about their day, how they're feeling. You all know Twitter. And so what they did, they wrote Twitter in a language called Ruby with a framework called Ruby on Rails. And Ruby on Rails allows you at that time, allows you still, to rapidly prototype and get up and running with a simple web application, and database, front end, everything. Yeah. But as Twitter would become more popular, because who knew, people like to talk about themselves. And so Twitter got more and more popular, and it started crashing. And people started to see this image, or this image. This was in 2008. And it was what would become to get to known as the fail whale. You'd access Twitter, you get this image. And this happened so much that it basically became a viral meme in and of itself. People would get tattoos of it. People would bake cakes of this little fail whale. That's how popular it became. But, of course, here's the problem. Why did Twitter crash? So, of course, there's the huge increase in usage. They did not plan for this. As I mentioned, Ruby on Rails allows you to rapidly prototype something, but it's not out of the box scalable to tens of thousands or hundreds of thousands of users. And that too, since they just to make some money, they didn't plan ahead. So yeah, there's some poorly written code in there, and if your foundations are shaky, then down the line that often bites you. But the main issue was something called server-side rendering, which Ruby on Rails is doing by default. So let's talk about what that is real quick. So what is server-side rendering? Imagine you are back in 2009. You open your browser, you access twitter.com. So let's look at what happened. We start at your computer, client computer, we send a request, what's called a request, HTTP request, to the internet. The internet, in all its magic and might, will route this request to a huge web server that's owned by Twitter. And this web server is backed by 1, 2, or multiple, let's just say multiple databases. Because you have to store information. If you're Twitter, you probably separate into at least a user's database and a tweets database. Pretty obvious what's happening. So you get that request, you need all those information. So the server would request information from the user database and from the tweets database. Gets it back, and then generates HTML. And HTML is what's rendered, basically, how your website looks. And this is rendered at this time on the server So it takes some time, and once everything is done, it sends that whole HTML back through the internet, magic routing, to your client, and then you'll either see Twitter or the farewell if it took too long. All right. So, but the problem is, this rendering, it's actually pretty costly if you scale it with the popularity of Twitter itself. So, but this becomes a problem. If you're Twitter, you don't want people to see the fail whale. So what they did, as many engineers do when they come across these problems, is they start refactoring their code. And refactoring is the process of basically trying to make it better. Emphasis on trying. So they would apply all kinds of techniques to try to optimize whatever they have. They would rewrite their poorly written parts. But still, it turned out to not be enough. So what they did then is they went to a company called Pivotal, which you've heard about from Kani. It's one of our partners. And what Pivotal does is they help them with their problem. And what they did is they actually ripped out a lot of the backend, the rendering logic, and rewrote that logic in a programming language called Scala. You don't have to know much about how Scala works. To say it in simple terms, it's a more mature language. It's faster and more reliable. And this worked for a time. Now Twitter didn't crash. Awesome. We're all very happy. Until this date. Who knows what happened on this date? Wait.
Michael Jackson.
Yes. Michael Jackson passed away. And you can imagine what happened next, or you can't imagine. No one could imagine this happening. Basically, the internet also just crashed. It had slowed to a crawl. It was in the news everywhere. Here's an excerpt from BBC. The whole web slows. And so you would get articles about this happening. And it would usually go like this. What's at that point was called a micro-blogging service. Just let that sink in, micro-blogging. Twitter crashed with the sheer volume of people using the service. Queries about the stars soon rocketed to the top of its updates and searches, but the amount of traffic meant it suffered one of its well-known outages. Man. So you're Twitter. You got popular, you got kind of a reputation for crashing, and you did everything in your power. You even got Pivotal on board to rip out half of your backend, replace it with something that works, and it's still not enough. So Twitter was out of ideas. They optimized everything, and so what more could be done? And kind of like a little voice that you ignore for a time. That's what they did. There was a little team at Twitter, and they were like, hey, why not do everything in JavaScript? But at this point, I want you to remember that JavaScript was still only used for just little updates on your website. It doesn't have the best reputation. It's a slow language. There's many downcomings to it. So they were just this little team, this little voice was just dismissed. Like don't take them seriously. It's just mad. But as I said, they were completely out of ideas, and the stakeholders they were getting angry too, because I mean they hold stakes in there, and you don't want to crash. So they went like, all right, let's try it. Right? What can go wrong? You're already known as the service that always crashes. So when they actually heard their ideas out, it turns out that their idea wasn't to actually write the whole server in JavaScript. It was a little something more cheekier. So their idea was, instead of rendering the HTML on the server, which is what's causing us all to crash, is to just have an empty HTML file and some JavaScript that contains all the data that the client would need to render it himself. So you would get the data you need. You would have the users, the tweets in JavaScript, and an empty HTML file. So much less work. It would get to the internet, to the client, and then now, ooh, the client does the rendering. Now, seems obvious if I just say it like this, right? But no one did this before. Nowadays, you'll see it everywhere. All these client JavaScript client frameworks that you heard about, React, Backbone, Angular, Vue, they all do this thing of just having an empty HTML file and JavaScript, and the client renders it. So, I mean, what's the advantages of this? It's pretty obvious. Since you don't have to do less work on the server, your server is free to handle more requests. It's not going to overload as fast. You also have a faster client experience if you are able to render that HTML. But the problem is, what I often hear is, but what if my client is not fast enough? What if my client takes too long to render the page? Wouldn't that be a bad user experience? Well, turns out it's not much of a problem. So here's a little graph that shows how much faster computers got over the last couple of years. 1995, when JavaScript was about to be invented, there were a lot of Pentium PCs, a name you rarely hear nowadays. But from that time, when JavaScript was still pretty slow and could maybe kind of handle that rendering, to now, computers have gotten over 100 times faster. And even your cell phone is very capable of rendering that JavaScript in the blink of an eye. So it's not a problem. But that's not the only thing. You also have the increase of internet adoption itself in the whole world. That has been increased too. And so what happened is that people realize, or companies realize that instead of having like internal privatized networks, you would have that a lot in the tourism industry, where one travel agent has a hidden network, and then another travel agent a hidden network, and you have all these separate networks. They realized it would be much easier to just have a web app or website and connect all those networks. Because, let's be real, at one point, probably everyone in the world will have access to affordable internet, or to internet itself. That will happen, pretty sure of it. So now they wanted, of course, you want to make use of that reach that your product can potentially have. All right, talked a lot, but haven't even mentioned the big player nowadays, something called Nodejs. So what about Nodejs? How did we get to a world where JavaScript is written on the server, where JavaScript is not just that little client-side thing that you send, but also written on the server? How do we go from a world where JavaScript, this kiddie language, this slow language, got so dominant? And this is one of the key points. JavaScript is slow. JavaScript is not written what we would call like machine instructions. If you compare it to C, C++, these are compiled languages that basically get compiled down to machine instructions that tell your computer what to do, and they are pretty fast. But with JavaScript, it's what it's called an interpreted language. So you write your little program, and then an interpreter has to go through that program and translate it on the fly so your PC, your computer, your Mac, whatever, can understand what it actually needs to do. And that is slow. Despite all of that, Node.js comes along. Well, I could tell you a lot. I could show you fancy graphs about speed, optimizations or not. But I like to ask, all right, let's approach it from a different angle. Who uses Node.js nowadays, and what do they have to say about it? Oh, a question? Do you have a question?
No, sorry.
Oh, okay.
Yeah, just I use Node.js.
Ah, yes. Oh, okay. Yeah. See, we have someone who uses Node.js already. Do you like it?
I like it. Yeah, it's not so bad.
What do you like about it?
Actually, because it's simple, we can like express. It's not so opinionated like Riven Rail is so you have to follow the rules, but when it's like express, you can do whatever you want. That's why I like it, and its community is really nice. That's why I like it.
Yeah. Cool. Thank you for that. So let's see what other big companies have to say after they made that plunge. Here's what PayPal had to say about when they rewrote their server with Node.js. Their new app was built almost twice as fast with fewer people, fewer lines of code, fewer files. Now, why do you think it would be easier to write it in JavaScript? Why was it built twice as fast with fewer people? Any guesses?
It must have skipped the middleman or something.
It's actually kind of close. So imagine you're PayPal or another big company, you probably have a web presence, you have a website. And with a website, you probably already have developers who know JavaScript. And so if you can make use of that resource already, you have people who know JavaScript, you just pull them from the front to the back end. Sure, there's different ideologies that you have to care about in the back end, but it's a smooth transition. And can you imagine how happy managers are if you can reuse the people you already have and don't have to be like, oh, can you post another posting for C++ server genius? I was like, no, we don't have the budget. Can you do it yourself? Well, now you can. Pretty easy. Okay, but that's just PayPal, just one company. Here's another one, LinkedIn. What do they have to say? The app is 20 times faster, a fraction of resources, servers were cut from 30 to 3. And this is nice parallel to Twitter. Their old app was written in Ruby on Rails. And at that time, they had 30 servers. Now they have 3. Whoa, what's going on? I mean, we knew that development itself, we know why this is, because they already know JavaScript, their front-end devs, they already know it. But what about, how does this happen, the other things? Why they can be cut down so much? So why does JavaScript seem so much faster? And is it really faster? Let's take a step back again to our little server. So, back to 2009, it's around about how the server worked, like Twitter. They use something called a sequential server, and let's just see what happens. So we have the internet, and we say 3 requests come in. 3 users all over the world just access twitter.com at the same time. So these come in at the same time to the web server. It needs the data from the user database, right? Now here's my question to you. What happens next? What happens next? What's the next step in this little diagram? Anyone want to make a guess?
Perhaps it gets the response from the database.
I hope it gets the response, but what if it takes a second or two to get the response? What if the user's database is overloaded and it needs a bit of time? What does this big Twitter server do in the meantime?
Like they make a stack, I think. They make a stack, and while like request one is like doing executing, maybe the case two will be executed.
So it would work on the other
like
requests.
Look concurrently like a parallelly.
Mm-hmm.
Yeah.
In parallel. All right. Anyone want to give one more guess? What? So I heard two things. Can one of you guys repeat, please?
I said it waits.
It waits, yeah, because you know how this works. Yes, so you have this big server, this big expensive server, sends a request, and then it waits. What? Yeah, takes a second, gets the answer back. All right, let's get some tweets. Oh, overloaded, takes 2 seconds, gets the answer back. Whew, awesome. Let's send the response to client 1. All right, let's do the same thing for client 2. Oh, still overloaded, takes a second. Whoa, man, send that back. Here's number 3. Yep. And by this point, when response 3 is going out, just imagine this scaled up to tens of thousands of people. This point, the person who requested that page already told his mom, hey, can you please bake a Fay Whale cake? That is the true story of how that cake was created. Someone accessed Twitter and it just loaded. And they were able to bake that cake while the page was loading. So how can you solve this? Well, there's another concept called an event-driven server. So let's just see how that works. Same outset, 3 requests at the same time. But now what happens is, what if you think about it logically, makes the most sense. They send all of those requests in one shot for the data to all the databases. Now, let's actually step back a bit. Let's say we are here. So we've sent all the requests for the user tweets, for the user database, and 1 request for the tweets database. Let's say there's already an answer from the user's database for one of those requests. This server is actually unable to see that. It has one thing to focus on. It's like, perfect, I have one thing to notice. It's like, I'm doing this now. I don't care if you're done. Let me do my thing. I'm sending requests to all the database right now. And then it checks, hey, are any of those requests already answered? So, and it doesn't matter in which order they come back to. It's like, once you have something to do, well, you do it. So let's say the users for request 1 come back. Then the tweets for request 3 might come back. Tweets for users for 2, tweets for 1. And now we have everything to create a proper response for user 1. And so on and so forth. And now this order is completely random. I don't know why the tweets for request 3 were the fastest. I mean, yeah, it doesn't matter. Basically, as soon as something is there to be done, the server does it. And it's one thing at a time. Can't be interrupted while I'm working. Wish real life would work like that. All right. So, my question to you is this. How do I write event-driven programs in JavaScript?
Do you have notion of multi-threading in JavaScript?
No.
Single thread.
JavaScript is single-threaded.
What does it mean for others who are not coders, single-threaded versus multi-threaded?
Single-threaded is basically how I explain it. You can focus on one thing at a time. If someone else comes here and says, hey, can you get me a bento? I'm like, nope, I'm just doing my meetup right now.
Maybe Nodejs has the framework has the.
Yeah, this is totally a trick question. Anything written in JavaScript is event-driven for free. It's how the language itself, the standard itself is designed. But that doesn't mean it's exclusive to JavaScript. Event-driven programs can be written in other languages, but that is very hard to do. And let me tell you that from experience. You'll have to write tons of things with fancy names, interceptors, handlers, priority queues, blah, 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 blah. And actually in an environment that is multi-threaded, where you can do multiple things at the same time, where I can give the meetup and get a bento for Kani, it's really hard actually to keep that simple and to make that work, because now you have to synchronize those threads, those tasks, and it's a lot of work. With JavaScript, it's super easy and it's not confusing. Sometimes, if you get into it, it might at the start, but it's actually very easy, very logical, and you don't have to do anything. It's done for you. So now, of course, still, we have JavaScript, we know how we can solve our problem of our server not doing anything, because if there's something to do, it's gonna do something. Another thing with JavaScript is it's pretty easy to use. It's very, very forgiving in how you write your code. And what I like to say is good software engineers are lazy. I told you, event-driven programs, they can be written in other languages, but why would I even want that if it's already in JavaScript and it seems to work pretty well? Then we have what someone mentioned, the whole community, packages in JavaScript. Other people who wrote libraries and frameworks for us that we can make use of. I don't need to write a front-end library. I can just pull on React. So, and if there is an easy way to accomplish something, that is often the best way. Now, keyword here is often. It's not always the best way. We've had troubles in our little JavaScript ecosystem where one of those fancy packages that hundreds of other libraries relied on got deleted, and like the whole internet freaked out. That's why it's often the best way, not always. All right. So, okay, we talked about a lot. Now have a way to make our server do everything, but that I haven't still addressed that question that's in the room. JavaScript's slow? Maybe you are lazy, but maybe speed is important to you. Or maybe there are other things you don't like about JavaScript. Is there anyone here who does not like something about JavaScript? Blake. Undefined. Undefined, void, yes, null. That difference, I totally agree with you. I saw Dylan too.
It's like math.
It's like what?
Floating point numbers and math, and stuff.
Yeah. So JavaScript is not just slow, it has a lot of weird things. I can tell you what I don't like about it, and I mean, it's kind of my job now to teach it to everyone, but still, doesn't mean I have to like it, is that it's what's called loosely typed. I can create a variable and say, hey, you, my little variable, you're a string. Yay! You say hello world. And then someone somewhere else in the program just goes ahead and reassigns that variable to a function or a number. And now all my other parts of the program crash. Thank you. Well, but it's not just slow. Wait, how do I transition to this one? I forgot. All right. So JavaScript, not perfect at all. No, I don't want to go out here and say JavaScript is perfect. It definitely has its fault. But isn't JavaScript slow? Yes, it is. But yeah, there are other big companies that have that same problem too. So here's Google, ain't Blake. Google said, we can handle the downsides of JavaScript. We don't care about loosely typing or undefined versus null or any weirdness you might have with that. And oh, I forgot to prepare this. Well, you are Google, right? You're a big company, Google. You own the world, basically. What do you do if you have a problem with something like this, but you kind of want to solve it? JavaScript is slow. What do you do as Google? Open question.
Make it fast.
Basically, yeah. So, I mean, you are Google, you have the resources, so you hire what I'm going to call a bunch of PhD genius wizard people that solve this problem for you. And so they did that, and the outcome of that is something called Google's Chrome V8 engine. Hope I got that right. And this thing is awesome. This thing is open source. It's in your browser, it's in Node, it's everywhere. And it's what solves the problem. And what it basically does is it takes your JavaScript code, it transpiles or translates it into C code, which you might have known already is one of the fast languages, one of the fastest. And then compiles that C code and runs it. Now, just saying this out loud, it makes you realize, wait, how is it faster than just going through the normal interpreter who does the same thing? It even sounds like more steps. Well, it's open source, so you can look how they did it. I looked at it, went over my head, I have no idea. That's why I call them genius wizard PhD people. It's very complicated, basically, but the only thing you need to worry about is that it works. Now, when you talk to people and they say, hey, JavaScript is slow, you can be like, no. It was slow, now we have this. Now it's fast. And I could again just show you some graphs of comparisons. I'm not going to do that. I'm going to ask the question, who is it fast enough for? Who else uses Nodejs? Or what I like to say, who else is lazy? Well, we already know about PayPal and LinkedIn. Another one is Yahoo. Uber, from the ground up, was built in Node.js. eBay. Oops. Netflix. Yay. So now you have all these big companies migrating their backend to Node.js, writing their servers in there. People want to get on board on that train. And not only that, not only is the problem of JavaScript being slow has been solved with Google's Chrome V8 engine. Actually, nowadays, a lot of those other gripes people have with JavaScript is solved too. And it was, a big advancement was something called the ECMAScript 6 standard. It's basically the way you write JavaScript. It's how you are able to write it. And it allows you to do things like write classes in a way that's very similar to other languages you might have already used. If you come from C# or Java or PHP, you'll be very familiar now being able to use a class keyword and extending other classes. Even though below all that stuff, JavaScript is still a functional language. So the barrier to entry for non-JavaScript people is actually lower too now. And a lot of those gripes are solved with this ECMAScript 6 standard. So people were migrating like crazy, and then Facebook at one point was like, all right, we use JavaScript to write the front end, we use JavaScript to write our server, let's just use JavaScript for everything. They wanted to use JavaScript to write applications for their phone. But you run into the same problem. It was pretty slow. But, well, we've already gone through this. What happens if you're a big company, you have the resources, you want a problem solved, hire a bunch of people, who are smart, geniuses, and they solve it for you. And that's how React Native was born. Now you can write your applications in JavaScript, and it gets compiled down to Objective-C in case of iOS, or Java in case of Android, and run that way. And it's fast again, but you're still developing it in JavaScript. So who else has their Android and iOS mobile apps made in React Native and uses JavaScript? Well, we know about Facebook. They created that library. Of course, they use it. And since they bought Instagram, they forced them to use it, if they like it or not. The new Skype app. Airbnb. Uber. Well, so the thing about the Uber app on Android and iOS, the main Uber app is not written with JavaScript or React Native, because let's say there are a couple opinionated people on there. And I probably would have been one of them a couple of years ago, where I say, I'm not going to touch JavaScript. End of story. But there was another team that wanted to do, had another app idea, Uber Eats, to deliver food via Uber. And they built their mobile app from the ground up in JavaScript, React Native. Yeah. Then you have Tesla and Bloomberg News. So, what I'm trying to say is that the main problem we had with the language is solved. It's not slow anymore. And the barrier to entry is lowered. It's very easy nowadays to find JavaScript developers. And just thanks to the development of Nodejs and React Native, as a JavaScript developer, you can work what's called across the stack. You have what you see, the web page, we call it the front end. You have whatever's happening on the server side with all these Twitter servers, for example. It's what we call the back end. And you can work as one developer with the same language throughout that whole stack. And this is going to be the way forward. I'm sad that I forgot his name, but one of the founders of Stack Overflow actually said in a quote, an application that can be written in JavaScript will be written in JavaScript. All right. And with that, I want to end it with a little Q&A session. You might have any questions. Yeah.
Usually, cross-platform languages have a lot of disadvantages, like lacking in certain libraries, or can't really cover all the words. I don't know. So I don't really speak good English. How I say it. I mean, when you write a code for Android or something, if you write it in Java, you have full possibilities. But with JavaScript, isn't there any restrictions or
Yes, that is also why that often was emphasized there. So yeah, especially with the mobile market, you have an existing big volume of packages and third-party things you can make use of, but you can also make use of those with JavaScript when you're doing React Native, because people will most likely have written a wrapper for whatever you're trying to use with just Java. So it turns out that most of the things, unless it's like something very very specific, most of the things can be done with just JavaScript and React Native and third-party packaging. Did that answer your question? Okay, cool. Anyone else? Any questions? Yeah.
Sorry, I don't know if everybody knows, but can you explain what a Nodejs is?
Yeah. Oh, okay. Yeah, I should. So Nodejs is just the name of a JavaScript framework that allows you to run. It's a JavaScript engine. So if you have your browser, your Chrome, your Firefox, they have what's called a JavaScript engine to run your JavaScript. And Node is an engine that runs JavaScript but outside the browser, as and gives you access to the resources of the PC or server you're running it on. So with Node, you can do things like load a file from your file system, which you cannot do in a browser because you're in a sandbox environment. You're not allowed to reach outside of your what you're supposed to do.
So this engine lives on your computer?
Yes, or a server anywhere in the world. Yes. Good question, thank you.
That's the same thing for React?
Yes, so React is a not framework, it's a library. No, wait. React is a library. React is not a JavaScript engine. It's something you pull down and make use of to create, I want to say pretty UI. But React is run on the client, so in your browser. You don't run that React in Node, because React is what you see. It's how your web page looks at the end. Right. Yes.
And I think you said you told us like the application will be written in JavaScript, but we can talk the data science. It's basically in like Python or something like that. But do you think, just I want to ask your opinion, do you think in the future, like in JavaScript, would it be good for data science or something like that?
Wait, can you repeat the question part again, please?
Actually, what is like data science?
Data science.
Data science.
Okay.
Usually, like library is in like Python, right? Then in the future, what does it mean? Like in the future, JavaScript, would it be good for data science?
So, what I'm not saying with this talk is that JavaScript will take over the world. There will always be a place for Python, C, C++, everything. The emphasis was on often. And yes, one of the specialities of Python, one of those, is working with, is having a lot of libraries for data science stuff. But what I've noticed is they are starting to appear, some libraries like TensorFlow.js that enable you to kind of do the same thing with JavaScript. But I agree with you. Currently, in my view, I see Python is better for data science. But I don't want to make a claim that JavaScript is going to take that specific part over, because I'm not as experienced in that whole field. So there's still, still pockets of specific specialties.
But a little while ago, you shared with us about the quotation. You said, anything that is not written in JavaScript can be, written in JavaScript in the future, right?
Yeah, it's a common quote you come across often, but maybe that's true. I personally still believe there will be little pockets of not everything, but a lot of things. Let's just say a lot of things. Yeah.
What other programming languages works best with JavaScript, or is somewhat similar to JavaScript?
That's an interesting one.
Is it that unique?
No, the reason I'm stalling is because usually when you use JavaScript, you use, of course, the other web technologies like CSS or SAS or whatever, but I don't want to mention those. Usually when I see JavaScript applications, they don't work a lot with other languages at the same time. It happens, but I just can't think of a specific example where where language goes well together with JavaScript on the server side or on the desktop application side. At least not off the top of my head. Any other questions? Yeah.
So from what I heard, these days it is getting more popular to use serverless, to make serverless application. I suppose, I'm not sure, but I suppose there is somewhat, relation between serverless and JavaScript. Am I correct? And could you explain exactly what the meaning of serverless application?
I cannot explain that exactly because I haven't worked with serverless a lot.
Okay.
But I know the basics that it's basically runs your code in the cloud, which is a lot of buzzwords, I know. But I know that you can still develop whatever application you're writing and deploy it in the serverless infrastructure. But that's about all I can say about that, since I'm not as versed in serverless deployment.
Okay, thank you.
Yeah.
We are not really related, but you can do serverless programming in probably, if you go by AWS, you can do Python, even .NET. So not related, but the most popular one right now is Nodejs serverless.
So it's basically just a way to run your code online without the infrastructure of a server. Yeah. Right. No more questions? Any more questions? Anything? Oh, yeah.
What about JavaScript in HTML5? Like if you look like the evolution of HTML going through that way, because JavaScript mostly is web. That's why I see application. I see like JavaScript is more like you have the interoperability between people, reaction and stuff. And HTML like the structure of the site, for example. That's what they always been. But then you have HTML5 coming up with new functions and everything else. You don't need to have a plugin for video anymore. You can do straight everything in code. Mm-hmm. And now you have maybe HTML6 coming up, I don't know when. And what do you see like the evolution of that? the function of both of them.
I think the holy trio of JavaScript, CSS, and HTML on the front end side will always, no, you don't say never or always, but will probably stay the dominant force. So they always, it's really hard not to say always, they'll probably continue working very well together. But you kind of, yeah, they work with each other, right? You have HTML to tell the structure of your website, you have CSS to make it pretty, and then JavaScript to make it fancy or flashy, I like to say. So, yeah, they always go hand in hand.
Yeah, because there's HTML5 prior to that, most of the time you need to have something else. But about HTML5, there's so much things that you don't need many other things to get with it.
Oh, definitely. I'm glad we have HTML5. I'm glad Adobe Flash is not a thing anymore. Maybe in some Japanese websites, but yeah.
Yeah.
All right. If there's no more questions, cool. Then I guess that concludes my little talk about JavaScript. I just hope I could transmit my feelings about, yeah, this is actually a serious language. This is the way going forward for at least a while to you, and that you should take it seriously. I mentioned it before. When I started out with JavaScript and PHP, it was right before all this happened. Well, yeah, kind of. A couple of years ago, right before React got popular. And I too was of the opinion JavaScript's a kiddie language. It has a lot of downsides, but it's actually the upsides of it definitely outscale those little annoyances you might have. Plus, there's tons of tools to get rid of the annoyances you still have left. Like if you like more typing, there's something called TypeScript. It's on top of JavaScript, and it gives you all those little safety that you might want from or used to from Java. Yeah. So with that, let's close this and let's use the time to network, or you can come up to me with any questions you might have. Yeah, you can use the space for a bit. What time is it? Yeah, let's say until about 9, so for 20 more minutes. And yeah, thank you for coming. And yeah, enjoy.